Hello students, this video is going to concentrate on the last method of module number 5, that is dual simplex method. Okay, so the name of the method is dual simplex method. Let's understand what do you mean by the dual simplex method. Okay, let's understand you're not supposed to calculate the dual here. Okay, the dual calculation is a separate question and a dual simplex method is a different question. Okay, so let's understand how do we go about. Before I start with this particular method, I'll quickly take a recap of the simplex method and then we'll start with this particular method here. Okay, so getting back to the simplex method, in the questions of simplex method, and I may take it as a comparison here. Here the question was always maximization kind. If it is not maximization kind, you converted it by multiplying by -1. Okay, maximize. This was the type of question. Here the question will always be minimize. In the simplex method, the constraints were less than or equal to. Here again, the constraints would be less than or equal to. So do not get confused. In the finding of the dual, the constraints for minimize are greater than or equal to, but then if we talk about dual simplex method, the constraints will be less than or equal to. If the constraints are not less than or equal to, you will multiply throughout by -1. And you know what to do when there's an equality sign. When there's an equality sign, you split it up into less than or equal to and greater than or equal to, and accordingly multiplying by -1, you will get the change there. Okay. In the simplex method, we used to look for negative most element in the Z row of the simplex table. And this would give you the key column or the pivot column. Okay. Now in the dual simplex method, you will again look for the negative most, but this time you will look at the negative most in the RHS column. Understand the difference? Here we were looking in the Z row. Here we are looking in the RHS column for the negative most. Okay. And this now is going to give you the pivot row. So the difference being majorly maximize and minimize. Constraints are both the same, less than or equal to. If not less than or equal to, convert them. Again, you're looking at the negative most element, but in the simplex method, you were looking at them in the Z row, and you found the pivot column accordingly. Whereas in the dual simplex method, you find the negative most element in the RHS column, and you will first find the pivot row. Okay. Next step after that was finding the ratios. Here you had a ratio column. Now the ratio column here was equal to the RHS divided by the pivot column entries. And here you will have a ratio row. And the ratio row would be equal to the Z row divided by the pivot row entries. Here to make the decision of the pivot row, you looked at the smallest positive element or the smallest positive number in the ratio column. Now this gave you the pivot row. Okay. Whereas in the dual simplex method, you will look at the smallest number in the ratio row. That will give you the pivot column. We have already got the pivot row, so now we'll get the pivot column. The intersection of the pivot row and the pivot column in both the cases is going to give you the key element. You have to always make the key element is equal to 1 in both the cases by multiplying by a suitable ratio there. Once you make the key element equal to 1 in both the cases, you convert the pivot columns into identity, that is 1, and all the other zeros. Okay, so I'll just write down in common, like these are the steps in common for both. You convert key element, which is the intersection of the pivot row and the pivot column. I'm using short forms. You convert this key element into 1 by multiplication by a suitable number. And then you apply suitable row operations to make zeros everywhere else in the pivot column. Okay, you use suitable row operations. We'll learn this in detail with the help of examples, of course, but these steps are common to both. Okay, not at all different for any of them, neither for simplex nor the dual simplex method. One more thing which you need to understand in the dual simplex method is this dual simplex method will fail. This method fails. Let me draw the divider. So the method fails if the z row is positive. So if all elements of the z row, if they are positive, the method does not work. Okay, so that's a small gist of this. We'll understand this better with the help of these sums. Okay, I'm going to take 2 sums in this particular video lecture. So yeah, let's begin with a question. Again, one question of this particular method expected in the exam for approximately 8 marks. We have seen multiple questions in the university paper for around 8 marks. Okay, the question is going to be very direct. The question is going to be like use dual simplex method to solve the following LPP. So this entire module, the name of the method will always be mentioned. So it is, in this case, it is dual simplex method. Okay, fine. So let's look at question number 1. As I said, I'll be doing 2 questions. Okay, the question goes with minimize z is equal to 2x1 plus 2x2 plus 4x3 subject to the condition 2x1, 3x2, 5x3 is greater than or equal to 2, 3x1, x2, 7x3 less than or equal to 3, x1, 4x2, 6x3 less than or equal to 5, and x1, x2, x3 greater than or equal to 0. So let's understand step number 1. The question is of dual simplex method. Look at rule number 1 of dual simplex method. Rule number 1, the question should be minimization category. Is our question minimization? Yes, our question is minimized. You can see here. Then rule number 2 says all the constraints should be less than or equal to. Now, if you look at the constraints, there's one constraint which is not less than or equal to. So step number 1 is going to be converting this constraint into less than or equal to. To convert it into less than or equal to, we will be using multiplication by negative 1. So we'll write this as minimize z is equal to 2x1, 2x2, and 4x3 subject to, because I'm going to multiply by negative throughout, I'll write minus 2x1 minus 3x2 negative 5x3 less than or equal to negative 2 here. All the remaining constraints will remain the same. And the last one is x1, 4x2, 6x3 is less than or equal to 5. No more changes in the question, okay? Because everything else is satisfied. Now, once we're done till here, we will have to introduce the slack variables for all the less than or equal to constraints. Because there are a total of 3 constraints, we'll have to introduce 3 slack variables. So when you introduce the slack variables, it is called the standard form. So we'll say the standard form is minimize z is equal to 2x1, 2x2, 4x3. Because there are 3 constraints, we'll have 3 slack variables. So 0s1, 0s2, 0s3. We'll have the constraints getting changed to negative 2x1, negative 3x2, negative 5x3. S1 will contribute to the first one and no contribution from S2 and S3, hence their coefficient remains 0. This becomes the equality constraint with negative 2 on the RHS. 3x1, x2, 7x3. No contribution from S1. S2 contributes and no contribution from S3. Equality constraint 3. Last equation x1, 4x2, 6x3. No contribution 0s1, 0s2 and lastly S3 equal to 5. So if you look at the coefficients here, it's 1, 0, 0, 0, 1, 0 and 0, 0, 1. That's an identity matrix. Okay, that should get created here. Also, we need to mention that x1, x2, x3, s1, s2, s3 all will be greater than or equal to 0. Okay, so this is your standard form. Once you have achieved till here, the only thing which you need to change now is you need to get all the coefficients in the z row to the left hand side and make it as equal to 0. So z minus 2x1 minus 2x2 minus 4x3, 0 if it is positive, negative, no difference. So I'll keep it positive. And this is equal to 0. Now we start with the simplex table. The simplex table, as we call it, it's going to have all the variables. So we'll have coefficient of all the variables, that is x1, x2, x3, s1, s2, s3, and we'll also have the RHS. On this side, we'll have the basic variables. So now let's understand, because there are 3 constraints, we'll have 3 basic variables. And generally we begin with the slack variables S1, S2, S3 here. Before that, there has to be a Z row, which is also a basic variable. So S1, S2, S3 and the Z row. Okay. Now let me just scroll it a little up. Yeah. Here, yeah, this is iteration number 0, you can say, because this is the basic first iteration where we are starting with. So this is iteration number 0. Okay, let me put some lines here so that it looks a bit more neater. So this is your table header. The next we are going to insert a line here. And we also have to draw one more. I hope this is clear. Okay, so yeah. And one more. Let me just, yeah. So our simplex table number one is not yet ready. No, still requires me to draw one more. Okay. So simplex table number one is ready. We need to fill in the values. To fill in the values, let's understand. We're going to first use the coefficients from the Z row. Coefficient of x1, x2, x3, s1, s2, s3. So starting with the coefficient of x1, it's -2, -2, -4. Then you have 0, 0, 0. RHS is also 0. For the S1 row, you will take the constraint number 1, that's -2, -3, -5, 1, 0, 0. RHS is -2. Constraint number 2 for the next row, 3, 1, 7, 0, 1, 0, and a 3 on the RHS. You have a 1, 4, 6, 0, 0, 1, and a 5 over here. I hope things are clear till here. We have prepared the first basic simplex table. Once we get this first basic simplex table, again getting back to the rules of dual simplex method, you need to find the negative most element in the RHS column that is going to give you the pivot row. Okay, so RHS column, negative most element. Observe, this is your negative most element in the RHS column that gives me the pivot row. Let me highlight it by drawing the arrow, and you can use a pencil to just circle it out. Okay, so this becomes your pivot row. Actually, the circling should go up to the RHS because you're going to make changes to the RHS also. Fine. After this, what is the point? You have to find the ratios. Where to find the ratios? The ratios will come at the bottom of the table. And this ratio would be equal to Z divided by pivot row. Okay. The ratio would be Z divided by pivot row. So let's calculate the ratio here. Okay. I may write it on bit of the side just to avoid. Yeah. Ratio is Z divided by pivot row. Okay. And I might just extend this a little. Fine. So let's find the first ratio. First ratio is -2 divided by -2. So that's going to be +1 over here. Okay. Then it's going to be -2 divided by -3. That gives me a 2/3. And then I have -4 divided by -5, which is going to give me a 4/5. The remaining ratios are actually not defined or either 0. We don't entertain them. 0 divided by 0, 0 divided by 0, and 0 divided by 1. We just leave it all aside. Okay, we are interested only in the variables, decision variables, that is x1, x2, x3. So now let's understand, identify the smallest number in the ratio row. Smallest number in the ratio row. So if you look at 2 by 3, that's going to be somewhere around 0.67, and this is going to be 0.8. So 0.67 is the smallest. So this becomes your pivot column now. Highlight the pivot column, leaving the ratio part aside. So now let's understand S1 row, which was your pivot row. So S1 leaves or exits and X2 enters. Okay. And this is your key element, -3. You can mark a star for the key element, or it is just visible as a intersection. Next step, you need to make the key element 1. You need to make the key element 1. Okay. So let's make the key element 1. Now to make the key element 1, what I'm going to do is you can use a pencil. Okay. Again, let's call these as, R1. Let me call it here, R1, R2, R3. Okay, you may not have so many colors, so using a pencil helps you. Fine, or you can just write here, row numbers or row. This is going to be Z row, and this is going to be R1, R2, and R3 rows. Okay, so your first operation is going to be R1 gets multiplied by -1 by 3 to make it 1. To make it 1. So again, we'll have to recreate the same table. Let me recreate the table here. I'll again have iteration number. I'll again have basic variables. This time the iteration number will be 1. Basic variables again will begin with z. We'll again have coefficients of, starting again with x1, x2, x3, s1, s2, s3, and we'll still have the RHS column here. Okay. Then we will also have s1 leaving, so that will be replaced by x2, s2, and s3. Let me make the boundaries. Boundary number 1, 2, 3, and the shifted here and there. I think that's enough. Fine. So now let's begin with R1 getting multiplied by negative 1 by 3. So that's the x2 row now. So negative 1 by 3 will give me a 2 by 3 here. It will give me a 1 here. Positive 5 by 3, a 1, negative 1 by 3, 0, and 0. And the RHS becomes positive 2 by 3. Okay. So this is your new row. This is going to be your new R2. So sorry, new R1, new R1. Okay, fine. Now using these values of R1, let me write down these values here. Say 2 by 3, 1, 5 by 3, negative 1 by 3, 0, 0, and 2 by 3. We're going to use these new values to convert the pivot column into the remaining elements as 0. So the remaining elements are the Z row has a negative 2. So Z row gets converted to Z row plus 2 times R1 new. Okay. Same way S2 row gets converted to S2 minus R1 new. We are supposed to use always the new entries here. Okay. Means R1 new. And S3 row gets converted to S3 minus 4 times R1 new. I hope this is clear. Okay. So once we're done till here, let's start filling in the table. Now we'll fill in the values of the Z row. Z row becomes Z row plus 2 times. So let's understand. It's going to be negative 2 plus 2 times 2 by 3, which is going to be negative 2 plus 4 by 3, which becomes negative 2 by 3. Correct? Then for x2, it's going to be negative 2 plus 2, which is going to make it 0. That's what we wanted here. For, I'm going to erase this calculations here. For x3, it's going to be negative 4 plus 10 by 3, because 2 times 5 by 3. So that's going to be negative 2 by 3 again. Okay. Then for the S1 row, we'll have 0 plus negative 2, 1 by 3, 2 times. So negative 2 by 3 again. For the S2 row, because there's a 0 here, the 0 remains and the 0 remains. And this becomes 4 by 3. This becomes 4 by 3. Okay. Moving to the S2 row. S2 row becomes S2 minus R1 new. So I'll have, let me do the calculations again here. So S2 has a 3 minus, again the same value, that's 2 by 3. That's going to give me a 7 by 3. You can of course use your calculators. Okay. Then I'll have 1 minus 1, which is going to give me a 0. which is what we wanted. Then 7 minus 5 by 3 is going to give me 21 minus 5, which is 16 by 3. The next is going to be 0 minus of minus 1 by 3, which gives me plus 1 by 3. Then 1 minus 0 is going to give me 1, and this is going to remain 0. And then lastly, we have a 3 minus 2 by 3, which gives me a 7 by 3 again. Okay, you can check these calculations with the help of calculator or do it in the rough as I'm doing it. Of course, in the exam, you'll have to maintain a rough sheet or a rough column or the last page of the answer sheet. Okay, because the table occupies almost the entire page. Okay, now moving on to the last row, that's R3 or the S3. Okay, let me name it as R3 itself here. Okay, this was R2 if I'm not wrong. This is S, and this is R3. Okay, fine. So let's fill in the values for R3 row. So I have 1 minus 4 times 2 by 3. So 1 minus 8 by 3, which becomes negative 5 by 3. This becomes 0 because of 4 minus 4. Then I have 4 by 5 minus 20 by 3, which becomes 12 minus 100 by 15, which is negative 88. Or am I going wrong? Oh, it's not 4 by 5, sorry, it's 6 minus. It's 6 minus 20 by 3. So that becomes 18 minus 20, which is negative 2 by 3. The next is 0 plus 4 by 3, which becomes 4 by 3. This remains 0 and this remains 1. Lastly, we have 5 minus 8 by 3, which turns out to be 7 by 3. Okay, you can check your calculations here. Now let's look at the RHS column because that's where we work on in the dual simplex method. The table is completed. The RHS, all the values are positive. Your step was to find the negative most value. So now understand when Z entries are negative and RHS is all positive, you have got your optimum solution. So we have found the optimum solution, and to find the values of the optimum solution, you have x2 is equal to 2 by 3 and Z minimum is equal to 4 by 3. Okay, so that's your optimum solution and no other variables are contributing. So we'll say that if RHS all entries are positive, therefore optimum solution is obtained. You may not write this as well, but I'm just writing for your understanding. Optimum solution is obtained with x1 equal to 0, x2 equal to 2 by 3, and x3 again equal to 0. Also, you have z minimum is equal to 4 by 3. You can always cross-check your answer by substituting x1, x2, x3 in the equation of z. Let's cross-check. If I look at the equation of z, which was given to me in the question, this equation. And if I put 0, 2 by 3 and 0, I'm getting a 4 by 3, which matches with my answer. And hence my answer is correct. If it's not matching, you have gone wrong somewhere. I hope the first question is absolutely clear. I'll take one more question just to make things more clearer. Okay. Okay, students, we'll now look at example number 2 here. The reason to take example number 2 is you should understand a little variety of questions and gives you a little more practice. Okay. So the main question remains the same. Use the dual simplex method to solve the LPP. The question is to maximize z, which is equal to negative 3x1, negative 3x1, negative 2x2, subject to the condition x1 plus x2 is greater than or equal to 1, x1 plus x2 is less than or equal to 7, x1 plus 2x2 is greater than or equal to 10, and x2 is less than or equal to 3. Given that x1, x2 both are greater than or equal to 0. Now, because the question is of dual simplex method, remember that the question should be minimized, whereas यहाँ पे maximize दिया है. Also, all the constraints should be less than or equal to. So these two are a problem. We'll have to change all the three of these. That is, we have to change the maximize part. We have to change the greater than or equal to by multiplying by -1. So let's do that first. So step number one, the question becomes minimize omega, which is negative of z. So when you take negative, you take it on both sides. 3x1 becomes positive and 2x2 also becomes positive. Subject to. The first and the third constraint require multiplication by -1. So negative x1, negative x2, this becomes less than or equal to and -1. Second constraint, no change. Third constraint becomes negative x1, negative 2x2, less than or equal to -10. And the last constraint remains again the same. We will now introduce the slack variables because everything is as per the requirement. So to introduce the slack variables, we'll have minimize w is equal to, we'll not write negative z here, okay? Subject to, okay, and understand there are like 1, 2, 3, and 4 constraints. Hence, there'll be 4 slack variables, okay? 0 S1, S2, S3, and S4. First constraint will have contribution from S1, so negative x1, negative S2, S1, all remaining zeros. And this becomes equality, -1. Then the second has contribution from S2, so all remaining zeros. This should become an identity matrix and equality here. Then negative x1, negative 2x2, S3 will have coefficient 1, remaining zeros, -10. Here a 0x1 because there is no x1 term. Okay. Now my constraints are ready. They've got converted to equality. We'll move to the simplex table. Don't get confused. This is dual simplex method, but the table name still remains a simplex table. Okay. The structure remains the same. So you'll have iteration number. You'll have basic variables. You will have coefficient of, write down all variables, that is x1, x2, s1, s2, s3, and s4 in this case. And then we'll have a RHS. Let me draw the lines here. The neatness of the table helps you, calculate better. Otherwise, a lot of chances of silly mistakes. So try to keep it neat and clear, not decorative, but then neat. Okay. This is going to be the Z row. And this is iteration number 0. Let's fill in the, okay, not Z here. This case, it's going to be the W row, correct? This case, it's going to be the W row. Also, before filling in the values, I'm going to just copy down the table just to save me some efforts before drawing the next one. And I'm going to paste it for the next table, okay? Okay. In this case, the W row is again going to be making W equal to 0 first. So W minus 3x1 minus 2x2. Again, the zeros may not be negative. Doesn't make any difference whether they are positive, whether they are negative and equal to 0. So let me fill in the coefficients, -3, -2, 0, 0, 0, 0, and RHS is also 0. Now, the 4 basic variables will come from the 4 constraints as S1, S2, S3, and S4. And let's write down the coefficients. First one is -1, -1, 1, 0, 0, 0, and the RHS is -1. Then you have 1, 1, and 0, 1, 0, 0. Then you have a 7 here, -1, -2, 0, 0, 1, 0, a -10, and lastly 0, 1, 0, 0, 0, 1. Let it be in a straight line. Yeah, and a 3 here. So I've copied down all the coefficients. So my simplex table is ready. Let's start working on it. To work on it, step number 1, find the negative most value on the RHS. So RHS negative most is -10. I'm going to highlight it because this is my pivot row. Once I get the pivot row, let me properly do it. Okay. Once I get the pivot row, I'll look at the ratio, which is nothing but Z divided by the pivot row. In this case, it's W divided by the pivot row. Okay. So -3 divided by -1 is going to give me a 3. -2 divided by -2 is going to give me a 1. All the other ratios do not matter because they are either going to be 0 upon 0 or they're going to be zeros. Fine. So we look at the smallest value here. The smallest value over here among 3 and 1 is 1. So this 1 becomes a pivot column, and you take the pivot column leaving the ratio aside. This intersection is your key element, that's -2. So what you need to do is you first need to number the rows. So this is going to be my W row, R1, R2, R3, and R4. And step number 1, we are going to convert the key element into 1 by multiplying by a suitable number. So we are going to multiply R3 into -12. So when you multiply R3 into -12, let's write down the values here first. And another thing which you need to note here is that S3 leaves and X2 enters. The pivot row is leaving and the pivot column is entering. So here when I write the coefficients, it's going to be S1, S2, S3 is going to leave and X2 is going to enter and S4 remains the same. Okay. Let me write down the required ratio. The required ratio now is multiplying by -12. So this is going to be 1 by 2. This is, okay, let me write it here. 1 by 2. This is going to be 1, 0, 0, -1 by 2, 0. And this is going to become 5. Okay. I'll again, like the last sum, write down these ratios. You can use the pencil here. Here itself, 1 by 2, 1, 0, 0. Don't get confused, okay? Or you don't need not write them. 0 and a 5. Okay. I've written those values and I'm going to keep the screen little. Okay, let me just zoom it out a little bit. Okay. The table is big actually. Fine. Now the entire column, pivot column needs to be made 0 except for the key element. Key element is already made 1. And using the key element, you have to do that. So the W row, it's going to become W row plus 2 times R3 new. Then R1 row is going to get converted to R1 plus R3 new. The R2 is going to get converted to R2 minus R3 new. And R4 gets converted to R4 minus R3 new. So these are the operations to be performed. Let's begin with W row. So the W row is starting off with -3, -3 and 2 times half. So that gives me +1. So that gives me a -2 here. Then -2 and 1 minute. Why did I do? Yeah. Negative 2 plus 2 is going to give me a 0, and then a 0 continues. This 0 continues. This is going to give me a negative, see, a 0 plus 2 times negative half, which is going to be give me a negative 1 here. Correct? And then we'll have S4 again having no impact. So S4 remains the same. That is 0. And RHS becomes 10 because it's going to be 0 plus 5 into 2. Okay? Simple mathematical calculations. I think you can check them out. Okay? Coming to, okay, let me now zoom in a little bit because we now do have space to skip the W row. Okay. S1 row. S1 row is going to become, that's R1 row. R1 plus R3 new. So minus 1 plus half is going to give me minus half. Minus 1 plus 1 is going to give me 0. 1 plus 0 is going to become 1. This is going to remain 0. This becomes negative half. This remains 0. And minus 1 plus 5 becomes 4. Okay. Remember, we are adding the new values, not the old values. So that you need to be little careful. Bit of precaution. Otherwise, you might end up writing the wrong values there. Okay. Next, we work on the R3 row. Sorry, R2 row. R2 row is going to become R2 minus R3 new. So subtraction, 1 minus half is going to give me half. 1 minus 1 is going to give me 0. 0 minus 0, 1 here. This is going to give me a positive half. This remains 0. And 7 minus 5 will give me a 2. Okay. So these are your values. And let's move to the last row. That's R4. R4 minus R3 new. So 0 minus half is going to give me a negative half. This is going to become 0, 0, 0, positive half, 1 as it is, and a negative 2. Okay. So we got iteration number 0. Okay, this was iteration number 1. We need to change this as well because it was a copy pasted table. Okay, we got iteration number 1. Now, once you've got iteration number 1, check for the RHS. There is still a negative value. There's still a negative value. So you need to find the negative most, that is this. This becomes your pivot row. And we need to calculate the ratio again. That's going to be W divided by the pivot row. So in the first case, I'll have negative 2 divided by negative half, which becomes negative 2 into negative 2, which becomes a positive 4 here. Okay, that's the required ratio. And 0 divided by 0 doesn't matter, doesn't matter, doesn't matter. S3 and S4 will not matter as well. Okay, so you can leave all of these other ratios. So there is only one option remaining for the pivot column. That's this pivot column. The key element being negative half. So here S4 leaves and X1 enters. X1 enters. Okay. Let me again see. I can copy paste the, yeah, I have, yeah. Okay. And this is going to be now iteration number 2. Let me write down the values here. S1, S2 remains the same. X2 remains the same. S4 will leave and X1 will enter in its place. And I think, yeah, that's it. That's all we can keep same. Let's write down the row operations, and for that, let me create some space here. Okay. So the row operations, again, naming the rows, W row, R1, R2, R3, and R4. Okay. R4, I will first multiply with a negative 2. So let's see what do we get here. Negative 2, if I multiply, I get a 1 here. 0 doesn't change. Let me write it to the right. 0 doesn't change. No change in 0 again. No change in 0. If I multiply by minus 2, this becomes a negative 1. And this becomes a negative 2. This becomes a plus 4. Moving to the other rows, I need to make all the other column entries as zeros, including the W entry, including the W entry. So this also needs to be made 0. Okay. So what are we going to do is we'll first write down all the new values here. That's 1. You will have to use a pencil. 1, 0, 0, 0, -1, -2, and a +4. Okay. And let's work on the table. Okay. W row, to make it 0, I'll have to do W plus 2 times R4 new. No, not 2 times. Yeah, 2 times. Correct. Then for R1 row, I'll have to do a plus half times R4 new. So plus half time. And let's work on also the R2 and R3. R2 row, I'll have to do negative half times R4 new. And R3 row, I'll have to do again the same, negative half. Okay, so be careful, we are dealing with fractions now. So let's first complete the W row, and I'll erase all of this rough work here. You'll of course require extra paper or a rough column at the side. Okay, W row, -2 plus 2 times. So that's going to give me a 0. That's what should be the impact. Okay, we are working on this thing. 2 times. Okay. 0 plus 0 is going to give me 0, 0, 0. Then I have -1 minus 2, right? -1 added twice. So -3. Then I have 0 minus 2 times -2, which becomes 4. And then I have 10 minus 8, which gives me a 2 here. Okay? So that's my W row. I hope I'm going correct here. Okay? Oh, we are adding them. Sorry. So this is negative and this is going to give me 18 because we are adding them. Okay. Not subtracting. So moving further, so this was basically plus. Yeah. Yeah. Now we move to the S1 row. S1 row. Okay, let me close this pen tab. Okay. S1 row. For the S1 row, that's R1. We are going to add half times. So the first entry is going to be 0. So let's understand these are all going to be 0. Okay. Let's not waste our time here. Also, uh, understand these values are 0 still. So all of these values remain unchanged. Can you see this? These values will all remain unchanged. So I'm going to just quickly fill in these because they'll remain unchanged. Okay. Now the only values to change is the last 3 columns. So let's change them. So we have a negative half plus 1 by 2 times -1. So that becomes a negative half and negative half, which becomes -1 here. And then you have 0 plus 1 by 2 times -2, which becomes -1 again. And the last one, which is 4 4 plus 1 by 2 times 4, which becomes a 6. Okay, I can check the calculations. Now let's check the calculations for, I'm erasing these. Let's check the calculations for S2. That's row number 2. It's going to be negative half subtracted. So half minus half times -1, which gives me a +1. Then the 0 minus half times -2, again giving me a +1. And then I have a 2 minus half times 4, which gives me a 2 minus 2, which becomes a 0. Now the last row here, the last row, that's R3. I'll just erase these again. R3 becomes negative half again. So negative half into minus 1 gives me a 0. Then we have a 0 minus negative half into minus 2, which gives me a plus 1. And I have a 5 minus negative half into 4, which gives me a 3 here. Okay, so we got these values. Little patience is what you'll require. Now let's observe the RHS. All values are positive. All values are positive. So we have found the optimal solution here. And let's check the optimal solution. The optimal solution is W equal to 18 and for x2 and x1 equal to 3 and 4 respectively. Okay, so both the decision variables are contributing. So since RHS is positive and the W row is negative, we have the optimal solution. And the optimal solution would be W minimum is 18 for x1 equal to 4 and x2 equal to 3. Now remember the question where we started off with. The original question is of maximize category, not minimize. And the question is about Z. What we found is the value of W, which is negative of Z, correct? So we need to resubstitute that because W min was 18. So we need to understand that Z max will be negative 18. Why negative? Because Z was negative W, okay? Because Z was, or W was negative Z. So you'll have a negative here. For, again, x1, x2 equal to 4, 3. And you can always check your answer, x1 and x2, if I put 4 and 3 in the question, original question. If you put 4 and 3 over here, you'll have negative 3 into 4, negative 2 into 3, which gives you negative 12, negative 6, which is negative 18. And this was your correct answer. Okay, these are verification steps which will help you determine whether you've gone wrong or correct. I hope the questions are clear. Fine. So that's all about the module 5. We've completed everything in module number 5. Okay, all the very best. Study well.